Good afternoon, everyone, and welcome to today's ISAS panel discussion on the Chandrayaan movement, India's moon mission, and the unfolding space race. Today's discussion looks at India's recent moon mission and the wider geopolitical and geoeconomic context around India's growing space exploration capacity. And to discuss this, we are delighted to have with us Professor Rajaram Nagappa, visiting professor, National Institute of Advanced Studies at the Institute of Science in Bangalore, and former associate director at the Vikram Sarabhai Space Center at ISRO. We are also joined by Dr. Rajeshwari Pillai Rajagopalan, director at the Center for Security Strategy and Technology at the Observer Researcher Foundation in New Delhi. We also have with us on the panel Mr. Chris Leck, Adjunct Senior Fellow at the S. Rajaratnam School of International Studies at Nanyang Technology University in Singapore. Today's session is chaired by Dr. Yogesh Joshi, a Research Fellow here at the Institute of South Asian Studies at the National University of Singapore. This session is also being live streamed on the ISAS Facebook page, and I now hand over the session to Dr. Joshi.
Thank you so much, Syed, for those introductions. Let me welcome you all once again to this very interesting panel, and rightly so. Almost a month after India landed its lunar mission on the moon, becoming the fourth country overall, but the first country to touch the south pole of the moon. And we have a very distinguished panel, as Syed reflected upon just right now. I think what is very interesting in this panel is the way we have structured is to understand what the Chandrayaan movement means for India as a rising space power, first of all, but also how it reflects on the ongoing space race among major spacefaring states, but also the new states which want to join this race. But also what one could see and observe is the decentralization in some sense of space exploration, more and more private players joining what was otherwise a monopoly of the state, but frankly, technology in some sense allowing for the first time a real possibility of geoeconomic exploration and exploitation of space resources. And this is happening in a state where the regulatory framework, both for militarization of space as well as space exploitation, is rather vague. And therefore, I think this panel is uniquely positioned to help us understand the dynamics of not only the Chandrayaan mission, but its wider implications, both geopolitical and geoeconomic. So without much ado, I would rather call the first speaker for this panel, Professor Rajaram Nagappa. Professor Nagappa, the floor is all yours.
Thank you, Yogesh. Thank you for having me, both with ISAS and chemistry. Good to meet with other panelists here. And as you had mentioned, we really are having an interesting discussion. Chandrayaan and the ancient space race. I was looking at the calendar, today's 21st September. Exactly almost to the day 2 months from now will mark India's 60th year in space. On 21st November in 1963, that is ISRO, those days it was called the Science and Technology Center, or Mumbai Equatorial Rocket Mountain Station. ISRO had not come into being exactly at that time. They launched a Nike Apache sounding rocket with a sodium vapor payload to herald India's entry into space. This was from the city of Trivandrum, now called Thiruvananthapuram. Okay. And the payload went up to almost about a little over 200 kilometers. When we reflect back, India's entry into space was in the quest of science. But interwoven in this moment of launch, if I may say so, were elements of geography, international cooperation, foresight, vision, exceptional leadership. The International Geophysical Year was very active during 1957 and 58, and Dr. Sarabhai, the founder of our space program, himself was a cosmic ray physicist, and his proposal to study the cosmic ray variations was included as part of the IGY studies. And he observed, and he and Dr. Bhabha both observed that the Soviets and the Americans were using Sounding rockets for upper atmospheric research in aid of the International Geophysical Year experiments. And maybe this was what sparked the idea and said we should also get into the Sounding rocket thing. I talked about geography. The importance of geography here was Trivandrum or Thiruvananthapuram is located close to the geomagnetic equator, and the atmospheric phenomena over the geomagnetic equator is slightly different from other regions. And anyway, in the tropical areas, the atmospheric sciences have a little bit more bearing. So it was important from geography angle. And another angle was uh, in this cooperation at the height of Cold War, USSR and USA both came with equipment. Their sounding rockets came to fly their experiments from this fishing hamlet called Tumba near Trivandrum. So this was the birth of the Tumba Equatorial Rocket Launching Station, which was eventually on February 68, uh, dedicated to the United Nations, and the facility was available for all countries to, even member countries, to come and participate. And initially, therefore, along with this, when we started the Space Science and Technology Center, there was a wide exposure to scientists, technologists, as well as people who were bringing in rockets and payloads from USA, USSR, Japan, France. Many countries came into these facilities. So they also brought rockets, and some of us, therefore, who joined at the time had the exposure to both these. So there was an unstated uh, uh, emphasis on self-reliance. If possible, yes, look at what others are doing, learn from that. Where necessary, maybe you can go in for licensed technology, but essentially this is to understand and leapfrog, and the emphasis was on self-reliance. The learning opportunities came through training, exposure, experimental projects, and very, very rigorous review system which came into hone our skills, create systems for contemporary nature, experimental communication, and remote sensing taking advantage of. At that time, the USSR came with free ride, if I may say so, for our experimental satellites. The French agencies, they invited us to fly our satellite in their experimental launches. So the opportunities were there, and these were used for honing in the initial technology application payloads as well as the satellites. So over this time, this has resulted in reaching contemporary levels in launch vehicle technology, Earth observation satellites, communication satellites, navigation satellites, and keeping in mind the importance of the scientific investigations, some scientific missions also. With the result, by the time in the late 80s, India had gained enough experience as well as started making missions which could help in understanding multispectral Earth observation from fairly large resolutions of the order of a few meters. Today, you are able to do sub-meter resolution imagery. Microwave remote sensing is possible. And there's a constellation, I think, in the civilian domain, perhaps the largest constellation of 13 Earth observation satellites, which are providing a host of services for development activities, whether it's forest, resources mapping, cartography, snow melt, floods, disaster warning, all these elements are available. Same way, communication needs in various bands are met with a constellation of 18 satellites, which support services like television, broadcasting, direct-to-home television, telecoms, VSATs, radio networking, strategic communications, and for societal applications. And as far as composite satellites goes, about 9 satellites are providing you the navigation and timing services and host services, both general nature and a restricted nature. Right now, it's a regional service for about 1,500 kilometers from Indian borders. To place these satellites in LEO as well as GEO, one needs to launch vehicles, and India has made enough very affordable access to space capabilities. So all these have been sort of essentially learning has helped us therefore for our so-called uh, Chandrayaan moment, if I may say so. Just to add, essential infrastructure to manage the space assets, of course, is important, as in place an elaborate system in terms of launch services, tracking, telemetry, telecommand, communication, and other essential ground sector infrastructure for space and concept. ISRO partners with universities, research institutions, welcomes international participation in some of the experiments it flies. So, in terms of astronomy, planetary science, foreign institutions are also provided with the opportunity, and data sharing is quite openly done. India's Mars orbiter mission has foreign payloads. The Astrosat has about 2,000 scientists from India and abroad have used the data from Astrosat for their research and publications. While India has developed technologies, crafted end-to-end missions, developed some extent of industrial support system, one thing we are lacking is perhaps in terms of the capacity. Technology-wise, we have this one, so the capacity has been slightly missing. Uh, at best, we have managed about 4 or 5 launches per year in the best of times. Now, if you want to really do much more, uh, I think we need to increase the capacity. Also, that also talks about the global space economy. India's share is just about 2%. And we hope by opening up the space sector, we can perhaps increase this by our participation from 2% to a much higher order. So keeping all this in mind, the government of India introduced a major space reform, which you just slightly referred to in this one in 2021. Significantly, the sector was opened up to the private sector participation. Policies were framed for catering to the demand-driven needs, and ISRO was mandated to concentrate on R&D, while the newly formed New Space India Limited will look after the production element, including the PSLV, cater to the emerging small satellite market. And the third entity is the Indian Space Promotion and Authorization Center, with prime goal to promote, enable, authorize, and supervise space activities of non-government activities. One important fallout of this is ISRO has set up a number of facilities required for this one. So government has mandated these facilities be available to anybody who wants to use it, obviously at a small cost. But these facilities, the private industry or the private players may not set up their own test agencies and qualification setup. They could use the facilities available with ISRO for many of their. And professional bodies like the Indian Space Association, SATCOM Industry Association, the Confederation of Indian Industries, they are also trying to see how the startups could be made more user-friendly type of this one situation they can benefit from. So today you have an infrastructure available which will address the capacity requirements. More than 100 startups are into the game. Okay, and with so much happening, ISRO is able to concentrate on new missions like human space flight, reusable launch vehicles, deep space missions, and Chandrayaan mission, which is the next example. This Chandrayaan 3 movement is not really the start of our Chandrayaan this one. If I look at our Chandrayaan type of journey, way back in the 1990s itself it started. Towards the end of 1999, the PSLV had reached a fair amount of good reliability. I think we had done about 4 flights in the 1990s, 4 successful flights, if I'm not counting the very first one, which had a little bit of problem. And that it gave us some confidence. So some of us started looking at what else can PSLV do. And one was, at that time itself, we came out with a suggestion to the higher management. PSLV is capable of putting about 1000 kg payload around the lunar orbit. It's easy to come out with suggestions because we sort of could prove what type of trajectory to take, how much mass it can be done, and all. But we were not competent in VSSC to look at what type of experiments should be carried on board. And Dr. Kasturi Rangan, the chairman at the time, looked at it, but he said, no, you can't be hurrying through. All right, you have a vehicle which is qualified and it can perhaps take a payload, but we should decide what that payload should be there and are we ready to do it. So he put it across 2, 3 levels of national level discussion, one within the space community, one within the scientific community, and now request to the scientific community, please tell us what useful experiments that could be done if you are in orbit around the lunar horizon. Uh, what could be? And that came out with the ideas of what could be done in the Chandrayaan 1 mission. So therefore, it was an orbital mission. The seeding was done in 1990, but it took almost 8 years to finalize what would be done, prepare the payload, invite international participation in this, and finally resulted in the launch of Chandrayaan 1 on board a PSLV in October 2008. Its mission ended about a year later after completing chemical, mineralogical, and photogeologic mapping of the lunar surface from a 100-kilometer orbit. Out of this, discovery of water ice was a major finding of this mission. Chandrayaan 2, which followed, was a much more ambitious mission, launched on aboard the new launch vehicle Mark 3 on 22nd July 2019. So this comprised a lunar orbiter, Vikram lander, and the Pragyan rover. All 3 elements were supposed to be done on this. On 22nd July, this was inserted into lunar orbit, and as of now, till the August 19th August 2009, it's continued to remain in orbit, and it's providing information and data. It did a remote mapping of the lunar surface, helped us locate what could be the good landing spot. Okay. On, on 6th September, the lunar Vikram lander was released, but it could not accomplish its soft landing task. I think at around 2.1 kilometer altitude from the lunar surface, it got into both a hardware and a software related issue and crashed on the lunar surface. So now to be outdone, ISRO pulled up its socks, went through a very, very rigorous review system as to what really caused the failure, and brought out the new this one, not only addressing the failures, but added more redundancies, added a little bit more ruggedness on the lander, reinforced its legs. And with all this, the Chandrayaan 3 was essentially as a follow-up mission, but with much more confidence, was launched on 6th September 2019. On this year, I'm sorry, I beg your pardon. And on August, with these changes, lander had a smooth touchdown on August 23rd, 2023. This has sort of ignited a lot of interest in space research in India, and the Prime Minister has declared the August 23rd to be celebrated as the National Space Day. And after about a day later, the Pragyan roller has rolled down the ramp. A day later, mission of the lunar as well as the rover is one lunar days, which is equal to 14 Earth days. There's a two-way communication between the lander and rover, and the lander is in communication with our Indian Deep Space Network. So, as a standby, the rover also can be used as a communication network. Now, the orbiter of Chandrayaan-2 rover can communicate only with the lander. The lander has 4 scientific payloads. Rover is a mobile laboratory moving on 6 wheels and navigation cameras. So these navigation cameras really help you to see that it doesn't get into a deep crater or anything of that variety. Rover will carry out in situ chemical analysis of the lunar surface and study the abundance of elements near the landing site. All the payloads have performed to date, and the results are communicated to the Indian Space Network, which now is being analyzed. Presence of sulfur has been confirmed. Other minor elements have been looked around. Up to 10 centimeters of the depth, temperature profile has been recorded, and it can be the temperature gradient is quite steep. I think surface temperature drop of 10 centimeters, the drop in temperature is very fast. This is one way to come. Now the lander and rover are in the sleep mode since September 4th. They come back to life on September 22nd. We are not very sure whether they'll be able to perform again based on the lunar uh, nighttime temperatures and the solar cells and the batteries being idle for such a long time. How much they'll come back to life, we have to watch and see. On 21st June 2023, India became the 27th signatory to the Artemis Accords. These accords, piloted by NASA, non-binding agreement of international partnership to play a key role in achieving sustainable and robust presence of the moon. With many countries, space agencies, private companies pursuing missions to the moon, a common set of principles needs to be evolved to govern the civilian exploration of outer space, especially the moon and other celestial bodies. I think uh, this is an important this one, how we are going to go about it. A lot of thinking is going on, and I think today India has the uh, tools, both administrative tools and the technological tools, uh, to progress this. I don't know whether I can share one screen which I have just shows. Uh, Let me see if I'm.
Yeah. So we need to kind of wrap up quickly. So if you can just do it right.
Okay, I just all I want to say is today we have capability in the launch vehicle. We are also working on the human space flight. We are also have an agreement with NASA now with regard to uh, training some of our astronauts, and maybe there'll be an astronaut mission to the ISS. So we have the tools today on the human space flight. We are working on a reusable launch vehicle technology. We have recovered payloads from space. We are able to manage very, very critical missions totally. So with all this capability, we are very confident of not only further missions to the moon, other celestial bodies, and I think India is ready to play a big role in space. Thank you, Yogesh. I'm sorry if I have slightly overshot the time.
No worries, sir. Thank you so much for that very interesting, exploration of India's space journey, and so organically. Nobody else would have done it except the person who really lived it. So thank you so much for that, for those comments. We will now kind of expand our focus of what this means for the global, the ensuing space race, both geopolitically, but as well as, regarding the prospects of militarization of space. And I would now request Dr. Raji to present your comments. Dr. Raji, the floor is yours.
Thank you. Thank you, Yogesh and ISAS for this timely webinar and the opportunity to share some thoughts on this. So clearly, India's successful lunar mission Chandrayaan-3 is significant in so many different ways. This was launched on a GSLV Mark III heavy lift launch vehicle from southern India in Sriharikota. The mission traveled for more than a month to land on the surface of the moon in the third week of August, demonstrating how far the Indian space program has come in terms of the technological advancements, in terms of the sophistication, and making India only the fourth country in the world the other three being the United States, the USSR, and China, to do a soft landing on the moon. And that really shows that these missions are still very complex, and we know how complex it is. Just a few days before, prior to the Indian mission landing, you had the Russian Luna 25 crash landing. And of course, this was India's second attempt at landing on the moon. Chandrayaan 3 came 4 years after the Chandrayaan 2 mission that had a hard landing on the moon surface in September 2019. So even though this mission reached the lunar surface, it ultimately failed because of a communication breakdown between the craft and the ground station, and at an altitude of 2.1 kilometers from the surface of the moon. So it just goes to show how difficult these missions are, and things can still go wrong. And prior to that, of course, India in October 2008, India did launch the Chandrayaan 1, which was largely an exploratory mission, but it also included a moon impact probe. And the mission did confirm the presence of water on the lunar surface and so on and so forth. So there have been, India has been on this journey for quite some time now, but I think each step, so it is clearly a sort of a major triumph for India and its space agency. This was the first time, for instance, India was doing a touchdown on a non-terrestrial surface. Landing on any surface brings with it difficulties that is of an order of magnitude larger than the missions that India had conducted so far. And this mission in particular required India to not only set an orbit around the moon, but carry a separate vehicle that will touch down on the moon surface while the orbiter still stays circling above, in a sense. And of course, adding to the complexities was the fact that India was landing on an unmapped section of the lunar surface, again, making in India the first country to land on the southern pole. So again, all of this goes to show that this is very significant for a small space program of the scale like that India's is, in a sense, because India traditionally focused on pursuing development agenda through communication, Earth observation satellites. But lately, there has been a greater focus on space exploration. So even as this is a major achievement for India, it is also a necessary step in the evolution of India's space program. And after the initial space race between the US and the Soviet Union, the pursuit of such accomplishments was considered unnecessary because outside of the bragging rights, for instance, these kind of missions were not seen as not producing huge amount of scientific value and so on and so forth. And even after the bragging rights were kind of lost in some of its value once the US landed Neil Armstrong on the moon, the 50th anniversary we celebrated some time back. But these pursuits have become all of a sudden a lot more critical. One is, of course, the practical value of these missions has grown. There is increasing interest in space mining, with many countries now seeing that as a potentially viable option. I'm not entirely sure, even as technically they may be feasible, but whether it does really make sense for you to mine minerals and other resources from moon and transporting back to Earth, whether it makes economic sense or not. So things of that kind are still questions to be answered. But the fact is that a whole lot of countries are getting more interested in lunar missions because of that. Many other countries look at lunar missions also as a way to set up a base there, a lunar base that becomes the primary base for your other interplanetary mission, for undertaking interplanetary missions. So that again, a lot of these countries are looking at from multiple perspectives, and space is becoming much more competitive. And that brings me to my second point. The Chandrayaan 3 may not have been in a regular, directly a competitive kind of thing, but it is certainly a reflection of the renewed space race that we see, at least in the Indo-Pacific. The US-Soviet space race petered out well before the end of the Cold War, but there is a new space race that is picking up following the rise of China, which has been a spectacular and quite consequential one for most of the Chinese neighborhood, the Indo-Pacific. China is, of course, keen on matching American and Russian accomplishments in space, but some of its activities in space has also caused a huge amount of security concerns, and that of course goes much like its behavior in the neighborhood. You ask any of the Chinese neighbors, I think they have a very different story to say. So its behavior in outer space is also forcing others into greater competition. For example, when China conducted the first anti-satellite test, ASAT test in January 2007, that was the first such test in more than 2 decades. Thus, other states began to feel the need for demonstrating their own capability and so on and so forth. There are, of course, China has managed to accomplish a lot, even in the civil space sector. But again, that is also seen as certain amount. There's a competition that is driving the kind of efforts that China is making. China is well ahead on a number of different scores, but India has scored some achievements also, including being the first Asian power to do a successful Mars mission. China had earlier partnered with Russia to send a Mars orbiting satellite in 2011, but that was a failure. Of course, China has since then gone on to have its own Mars mission, also successful program. So even as India's space program is far smaller, less capable than China, all in relative terms, India does want to stay in the race with China's space accomplishments. Space has become yet another area of great power competition, major power competition, and India increasingly partnering with Western countries in this emerging global space race. And of course, the fact that during Prime Minister Modi's state visit to the US, India signed the Artemis Accords, which is, as Prasanna Gupta said, which is the US-led lunar cooperation and governance mechanism. The Artemis Accords are driven by key principles such as space, peaceful exploration, transparency, interoperability, registration of objects, preserving outer space heritage, preventing harmful interference, safe disposal of space debris, all of which are, in a sense, enshrined in the Outer Space Treaty of 1967, which is a foundational legal instrument that governs outer space activities. But critically, the Artemis Accords don't have Russia or China as part of it. And India signing on to the Artemis Accords is a departure of sorts, because India traditionally preferred to remain unaffiliated when it came to space programs, though it received considerable assistance from the US, France, and the Soviet Union. The fact that the India has now also agreed to be part of the astronaut mission to the ISS and possibly in 2024. So there are things that are changing quite rapidly in light of the geopolitical dynamics that we see in the Indo-Pacific and beyond. Let me take a quick a few minutes to just talk about some of the space governance issues from a security and weaponization perspective. So one point that we often tend to kind of confuse and used interchangeably is the term militarization of space and weaponization of space. Militarization of space is something that has happened for quite some time, with most advanced military or most militaries around the world using space assets for a number of what you call passive military applications, mostly ISR, intelligence, surveillance, and reconnaissance missions, some use for communications, and so on and so forth. But that's now seen as something acceptable within the space security in the space security context, and that's perfectly fine with most countries, including India, is comfortable with that understanding. But the problem comes, and the trickier part is now when states are truly weaponizing outer space. And by weaponizing space, I'm not saying that you have to necessarily put a weapon in outer space to weaponize space. You can use ground-based assets, targeting assets in outer space. So a ground-based missile in an ASAT weapon being shot from the ground, but to target an asset in outer space is space weaponization. And that is something that trend is what everybody is trying to deter, manage, and so on and so forth. By and large, outer space was considered a very peaceful domain until a decade ago, but I don't think we can hold that, say that with any certainty anymore. The situation has been progressively worsening, with countries pursuing destructive activities in outer space, and ASAT is just one capability. The kinetic ASAT capability is just one. There are other ways of countering, other ways of creating disruptions, damaging space assets, which include cyber and electronic warfare in outer space, which are becoming much more attractive options for a number of countries. And some of these capabilities, I must say that these have existed in the past as well. During the previous Cold War, we did see some of those capabilities. But by and large, space was primarily used for strategic functions during the Cold War years, whether it is execution and verification of arms control thing, or the strategic communication and so on and so forth. So space had a limited role during the Cold War between the US and USSR. But today, the more permeated nature of inclusion of space into conventional military operations has made space a much more attractive option to to target for states like China, that has been increasingly doing this. In actually since 2008 onwards, China has been testing a number of these capabilities, creating disruptions, almost hijacking the full entire command and control of a satellite and so on and so forth. And so that's one set of issues that are becoming seriously problematic. There have been several efforts in recent times undertaken to precisely to moderate the kind of activities that we engage in outer space. And the most recent one is, of course, the open-ended working group on reducing space threats through norms, rules, and principles of responsible behavior. In fact, it had four 5-day sessions between 2022 and 2023. In fact, the last session was concluded on September 1st. But given the contentious and competitive dynamics of great power relations that we're seeing today, the open-ended working group could not arrive at a consensus. This was a repeat of the 2018-2019 UN group of governmental experts. I was a part of it as a technical advisor. And that was a GG, or group of governmental experts group to work out something on prevention of arms race and outer space PAROs. But again, ended without a success, without a consensus report. So competition is spreading at a much fast pace. So I talked about the ASATs and cyber and other counter space capabilities. That is one set of issues. But states are also increasingly developing military space specific institutions. So China's creation of the PLA Strategic Support Force is one case in point. And the fact that that PLA SSF combines multiple portfolios of space, cyberspace, and electromagnetic domains makes it a much more potent force to reckon with and adds to the overall competitive dynamics that we see in the region. Similarly, Russia has come out with an aerospace division with similar functions. The US has, of course, a Space Force. And India has come up with its own DSA, Defense Space Agency, which is more of a coordinating agency than the PLASSF. So there are differences but the fact is that there are these military-specific space institutions that are coming up that adds to the competitive dynamics, that adds to the mistrust in the region among players, and so on and so forth. So that's, again, a serious problem that we need to think about. The next one or two couple of very quick points is one is the relating to the competition outer space that is leading to dilution of norms of responsible behavior. Norms that guided outer space activities for several decades in maintaining the sanctity of space are being overturned. The space regime included, of course, legal instruments, rules, norms. Even though not binding, norms have remained as important as legally binding rules, but for more than a decade now, these norms are being broken. First is the norm to not test ASAT weapons was not a binding measure, but it was a commitment that prevailed for more than 2 decades. In fact, last to be ASAT test by the USSR was sometime in the mid-1980s. But since then, both countries decided that this was being destructive in nature. This was not adding to the sustainable use of space and so on and so forth. So they had put a stop to it. But then comes the Chinese ASAT test in 2007, breaking that norm that prevailed for more than 2 decades. So that really gave way to the US Operation Burnt Frost, its own ASAT test in 2008. And of course, a decade later, more than a decade, 12 years later, India came up with its own ASAT test demonstration in March 2019. And given the competitive dynamics in space that I see, especially in the Indo-Pacific region, I can see many more countries likely to go down this particular path. A second norm that's been increasingly violated recently is the non-interference in each other's satellite operations. And that was, again, a norm that prevailed for a relatively long period of time, but increasing number of cyber and electronic warfare incidents have hampered the functioning of satellites and other space assets. And I think dilution of norms is not taken seriously by some states, saying that these are not legal measures, and therefore having legal measures have not really guaranteed space secure, a secure space, or that states are not breaking them, and so on and so forth. So, but the fact is that this is a slippery slope that can drive major powers, major space powers into a negative spiral unless some effective steps are taken. And I'm not really seeing any effective regulations. I don't know what we are waiting for. Are we waiting for a major catastrophe to happen, then realize that we should have done something about moderating the kind of behavior, kind of engagements that we engage in outer space? I think I'm almost out of time, so I'm going to stop, but I'll be happy to hear your thoughts, any questions. Thank you.
Thank you so much, Raji ma'am. So underlining the geopolitics, which is increasingly fraught by what I would call space blocks or alliances,
Yeah.
but also increasing weaponization, and that too, both these dimensions are taking place in a context of regulatory vacuum, so to say, and that brings us to our last presentation today, which also is going to capture a very interesting facet of the new space race, which is both the decentralization of space in some sense with the involvement of private players, but also when we are talking about lunar economies today, the economic aspects of space race, and that is something which is very interesting in the current dynamics. So without much ado, I will hand over the floor to Mr. Lek. Mr. Lek, the floor is all yours. Thank you so much.
Thank you very much, Dr. Joshi. Just give me a second while I try and share my screen so that you can see my slides.
Yeah, please take your time. Please.
All right. Can you see my slides? Okay. So I've been asked to speak about the commercial space economy, I think as a follow to what Dr. Raji and Professor Nagapal spoke about earlier. And I thought this was quite interesting because really, as I think Dr. Joshi mentioned, we are really seeing what folks have called new space. I mean, it's not a very imaginative word, I guess, but it really, those two words are meant to convey that we are in a different space age almost, where in the past, we are talking about space being dominated by governments and by the traditional military space industrial complexes, the big aerospace players. But today, we see many new players coming into the sector. Some are startups, some are young ventures. I think SpaceX is very well known. I think if you look at the picture on the screen, this is a picture of a proposed private space station by a few companies that have formed a consortium, Voyager Space, Lockheed Martin, NanoRax. And the interesting things, they are getting some funding from the US government, but actually the bulk of the funding that they need to build this space station, they intend to raise through private means from venture capital and other private funding sources. And this is just one of up to potentially 4 or 5 private space stations that folks have talked about putting up in space by 2030. So I think we can really see that shift away from government dominance to perhaps the increasing role that the private sector now plays. Okay. I thought it's interesting maybe just to quickly go over what the space economy is, because I think some in the audience may not be so familiar with what we're talking about when we say the space economy. I think if you look really at the bit of the slide on the right, it shows various space domains that are now coming into play. The traditional ones that most of us know about will be things like Earth observation or remote sensing, satellite communications, global navigation, the use of GPS or other GNSS means to help with knowing where we are on Earth to enable things like logistics deliveries and so on. But increasingly, we're talking about new areas like space situational awareness, knowing where all the objects in space are today, which actually, surprisingly is not such an easy thing to do. And I think many countries, even the US, are still struggling with this. Also things like in-orbit economy and space exploration. I think, was it Dr. Raji who spoke about this earlier? Folks are looking to do mining activities on the moon. But to support that, there are people talking about converting lunar regolith, the soil on the moon, or lunar ice, right, into things like oxygen, hydrogen, water, which we need for humans to survive on the moon, but also to provide propellant for spacecraft to operate. So it just shows, I think the increasing diversity of the sector. On the left side of this slide, I think you see basically what most folks will consider the value chain of activities. Perhaps less important for today's discussion, but I think just to highlight that, there's what people have called upstream activities, things like the building of satellite or space craft, payloads, and the like, basically your hardware and the equipment, also things like ground segment systems, launch vehicles, rockets, and so on, right? But also moving, I suppose, midstream into the operations that are needed, in space to maneuver and operate some of these things, to downstream activities like how you can use data that's being produced by, remote sensing satellites, by GNSS satellites, and so on. So that's just a very quick snapshot of the space sector. But looking at, where we are today, if you look at the left side of the slide, this is a graphic that I took from Bryce Tech, which shows the state of the space economy back in 2019. And really, we're talking about $366 billion economy, and actually a large part of that is not made up of government space programs. If you think about it, the quadrant, I think, on the upper left-hand side, that's really the amount of money that perhaps governments spend. But then you have other sectors like satellite communications, GNSS related services, and so on and so forth. They're really more in the private domain. And there are forecasts that say that by 2030 we can expect the global space economy to more than triple to $1 trillion. Of course, there are different forecasts. Some are a bit more pessimistic. They say that we'll reach the $1 trillion mark maybe by 2040, but there are also those that are a bit more optimistic and say that we can breach this $1 trillion benchmark by 2030. But just looking at the amount of private capital that's been invested into the space sector is tremendous. I mean, $47 billion has been invested into over 600 companies, and this is private capital. This is not government funding. So you can see that amount of interest really from the private sector in space. And of course, even where we are today, 77% of this sector today is in a way commercial versus government programs. So what accounts for this rapid growth? I see a couple of factors on the macro trends perspective. I think one is really that we have over the past decade really seen this increasing focus on digitization and connectivity, big data, because really of the internet age, I guess, resulting in more and more demand for data and connectivity, which space assets are now providing. The second bit is, in terms of ESG and climate action, I think over the last several years, of course, that's also been top of mind for many folks. And there's this huge global push for ESG and climate actions. And again, space applications and data enable us to meet those needs. Finally, of course, we have strategic rivalry, which I think Dr. Raji talked about, where because of this strategic rivalry, governments are increasing their spending on space, both on civilian space activities, but also on the defense side. And we've seen, I think, numerous countries creating space forces as well. So these are the macro trends driving this growth. But I think if you look at it from the micro perspective as well, there are several trends that have also enabled this, right? And one is really that technology advancements have really allowed for miniaturization of space systems, their payloads, sensors, and so on. And that's really given a boost to our ability to put stuff up in space. Of course, tied to this is really that there's been a lot of innovation when we're talking about launch. The one that's often in the news is reusability. How SpaceX, for example, is reusing their boosters and thereby really enabling them to save on costs. But there are other things like advanced manufacturing techniques like 3D printing that really allowed these launch providers to really bring down costs. And of course, we're talking about micro launches also come into play, where there are many companies, I think even many from India, that are developing smaller rockets that allow you to deliver your payloads where specific to where you want, rather than hitching a ride on a bigger rocket that may drop you off somewhere, but it may not be where you need to go, and therefore you have to maneuver yourself to the exact orbit that you would like. Right, so all of these, I think, have helped. New business models as well. We talk about as a service models right here on Earth for many different sectors, but in space as well. There's now space as a service business models that really, in a way, democratize access to space and allow many small players now to partake, I suppose, in space activities. Finally, access to funding, as I think I mentioned in the last slide, there's been increasing interest from investors in the space sector, and it's now much easier for space players to fundraise today. So I thought I'd just show a few pictures to illustrate, the changes that we're seeing over time. I mean, if you look at the satellite on the right, it's not a very old satellite. Actually, this is the Worldview 3 satellite that I believe was deployed maybe in 2014, I think. But that satellite on the right costs $650 million. And then you have the Dove satellite on the left by a company called Planet Labs. It's a startup that has already gone public by a SPAC, I believe. The other satellite costs about $600,000. So it's 6,000 times cheaper, compared to the Worldview 3 satellites. So, this is really, where we are today. And, when I talk about democratization or access to space, I think this I thought really illustrates this. But the other thing which I wanted to highlight is also I talked about the, innovation in launch, really increasing affordability and ability for folks to get up into space. So if you look at, maybe the chart on the right, even where we are today, this estimate says that it currently costs about $1,500 to launch 1 kilogram up into space. By 2040, the forecast is that this will come down to $100. If you think about it, $100 per kilo, that's about the price of, what is it, maybe an economy class ticket or a business class ticket, maybe for us today, right? To send one of us up into space. So can you imagine once the costs come down so significantly, what it means? I mean, any of us, right, could potentially send something up to space to do, what we need to do. But with this also, I think this is another chart that showcases the amount of new satellites that can be launched. And I think there are some forecasts that say that the number of satellites in space could exceed 100,000 by 2030. So it could be, potentially worrying if you think about it in a few ways. But maybe I'll touch on that a bit later. But I just wanted to very quickly also talk about the potential new industries that could arise as a result of this increasing accessibility. I think, maybe going from right to left, asteroid or space mining, I think Dr. Raji spoke about. Space exploration, of course, everybody knows about that interest in, going to the moon, going to Mars and beyond. But not many people may know that there's increasing interest in space-based solar power, having your solar power stations be put up in space, and then for the energy that they generate to be beamed back to Earth. It was a very far-flung theory, in the past, but increasingly today, there's been a lot of work done on the at least theoretical aspects of this, right? And so now folks are talking about how perhaps they can build the first space-based solar power station up in space within the next few years to really bring this theory into fruition. But of course, I spoke about this earlier as well. There's also increasing interest in having commercial space stations, not just the International Space Station, but also commercial space in potentially 4 or 5 by 2030. Things like space tourism as well, because of that accessibility in terms of launch, getting a ride into space, even for humans. We've already seen SpaceX in a way sending space tourists up to space. It's still fairly costly. I think SpaceX charges about $50 million per seat. At a more affordable rate, you have the likes of, I suppose, Virgin Galactic, and so on. But still, you can see really these are the kind of things that are really happening. And of course, once you have the access to space, being able to manufacture many of the things that we can't do on Earth today, but we can potentially do in space, that opens up huge possibilities. One example is 3D bioprinting. Today, if you try and 3D print a human organ on Earth, it's difficult because of gravity and organ collapses as you're trying to print it. But because of the zero gravity environment in space, Potentially, you could do something like that in space and then bring the organ, that's been printed back on Earth. You could do the same for tissues, and there's a lot of research being done on pharmaceuticals as well. Because of the space environment, you can produce pharmaceuticals. They're a lot purer than what you could, perhaps, back here. Similarly, if we're talking about semiconductors, there's a lot of interest in whether you can produce semiconductors or related products up in space, simply because of the unique space environment. I wanted to wrap up first by talking about some challenges. One, of course, is that we do need to think about equity, right, in terms of access, not just access to space, but also access to space technologies and space data. We want to make sure that increasingly that gap between the haves and have-nots doesn't grow in a way, and that that all of us who need to benefit from the data and technologies that are generated can do so as this commercialization effort takes place. Secondly, of course, is space sustainability. Increasingly, we're talking about perhaps up to 100,000 space objects, actually more. I mean, these are just satellites in orbit by 2030. We're not even talking about space debris, right? Where today, I think, if you're talking about space objects that are larger than 1 centimeter, much of which is debris, there's already more than 1 million pieces of such debris that we can count. For debris that's much smaller, I think some of the estimates put it in the range of tens of millions, if not more. But because they are so small, I think with the technologies that we have today, we can't really detect them. But these numbers are generated from modeling exercises that have taken place. So how do you make sure that the space junk that's up there, the mega constellations that are being launched, can be, these can be all done sustainably, and it doesn't affect access to space by others later on. And of course, we want to make sure that the activities that are done up in space continue to benefit meet terrestrial ESG goals as well. I mean, one of the questions that a lot of folks always ask, as we do more and more launches into space, these are activities that emit a lot of carbon, right? So how can you make sure that launch is a sustainable activity and doesn't add more carbon, So there are some of these questions that are also out there that I think need to be addressed. Finally, I think Dr. Raji has really mentioned this, the space law regime hasn't really kept pace with, I think, the explosion in the space economy, the activities in the space economy. So we do need to make sure that there are comprehensive rules and norms that are in place to help us to manage some of these activities. So I'll just stop here. I'm mindful of time. Thank you very much.
Thank you so much, Mr. Leck, for such. I really enjoyed, learning through your slides and the various aspects of the geoeconomics. And I would use your phrase, democratization of access. I think it's a wonderful phrase to kind of capture what we are looking at in terms of or one can say the liberalization of space economy in some sense. So that was extremely informative. Let me take the prerogative of the chair and before the questions come in, to ask you all a series of questions, which when I was reading through some of, making my own notes for this discussion, I was very curious to kind of pose those questions to you. So starting with Mr. Leck in the reverse order. So I'm really kind of, in some sense, the privatization of also space is in some sense akin to, or I fear, would also lead to, in some sense, privatization of weaponization of space. And I'm talking about the Ukraine crisis, and Elon Musk's satellite networks being used by Ukraine in a sense. So do you fear somewhere down the line that in some sense at some point in time the private players might provide access to military utilities for space, and what would that mean? And that poses serious questions not only in terms of the economics of space, but also for deterrence. So if you want to deter, are you going to deter a private player rather than a government entity? In that, so there's very curious interlinkages between the privatization of space economy and what does that mean for the conventional way of how space countries have signaled to one another in terms of the military space. The second question is about the Outer Space Treaty. So Outer Space Treaty does not really talk much about exploitation of space, right? It's much more focused on peaceful uses of space. And the new formulation which is coming out of states such as the US, the new interpretation is that because it doesn't really talk about exploitation of space, until unless it's peaceful, it is allowed. But then the question is, with the privatization of space economy, who is going to own it? So if I'm going to put my marker out there, whether it would be a private player which would own a part of the moon, or would it be the government? So that kind of questions, have not been addressed by whatever regulatory framework we have. In some sense. So what kind of discussions are happening in terms of ownership, of the space economy and space assets? So that is for you, Mr. Legg. To Dr. Raji, it's very interesting to see, as I said before, the emergence of these space blocks. And what we saw during the Cold War was some kind of great power condominium, in some sense a consensus, which emerged through interactions between the Soviet Union and the US. But this is clearly much more of in some sense what I would say a clear division between major space powers. We see that competition happening with China, Russia coming together for the International Lunar Mission, and the Artemis Accords, for that matter, right? And there's this democratic versus authoritarian space, space programs in some sense. So the geopolitics is putting that is giving a very different color to the current space race. And where is this alliance dynamics? Are we really looking at space alliances now? The second question which I would put to you is that this is the explanation on militarization and weaponization is very pertinent, and many a times, as you said, we confuse the two. But insofar, do you think that there is, and given more and more states want to prove their capabilities, what is driving it is the fact that at some point in time a regulatory framework would come out, and therefore if we have the capabilities, we can leverage to have not only a seat on the table, but certain prerogatives, right? And NPT in that sense becomes a template for many of the states. So what does this mean for the emerging regulatory discussions around space capabilities? Lastly, to Professor Rajaram Nagappa, so ISRO has, ISRO was in some sense kind of reflected how public science is done, right? For the people, and that was in some sense one among, if you compare it with the nuclear program, ISRO kind of provided public science, much more civilian, for much more civilian purposes. Do you see, in some sense, as Dr. Raji reflected upon the emergence of militarization of space, is ISRO's mandate also shifting from its civilian focus to military focus? And the second thing, which is pertinent to ISRO, and you reflected upon what ISRO is capable of doing, its varied missions and its ambitions, but this issue of budget here, right? We have made a virtue out of out of penury in some sense. But is there a reflection or a debate that, if we really want to be a serious player in space, we might have to at some point in time put the money wherever ambitions are. So all these questions, and I'll start with Mr. Leck first.
Right. Thank you, Dr. Joshi. Well, maybe let me start with your second question, right, about the exploitation of space resources. I mean, actually, I think both of your questions are right on the mark, in that unfortunately there are no answers. These are areas that folks are talking about right now. For the longest time, I think it was never really on anybody's mind that a private player could go up into space and access space resources. I think that's why if you look at the way the space treaties that we have today, the 5 of them, they were drafted in the 1960s, 1970s. They are very much state-centric, right? They talk about the roles of government, but I think there really wasn't that contention back then that you are going to soon have private citizens, private companies going up into space and doing stuff in space. So unfortunately, in a way, the current treaties and instruments, they are there. As you rightly mentioned, they don't really talk about this. All the outer space treaty talk about, for example, is that there should not be any national appropriation, right, of space, and that's the word they use, national appropriation. And of course, you can interpret that however you like. There are, I think, countries, of course, that talk about national appropriation being the same as imposing your sovereignty, over a particular part of space, which is not, I think, what anybody is talking about here, right, when we're talking about using space resources. So it's a conversation that's ongoing. The Committee on Peaceful Uses of Outer Space has a space resource working group that started work talking about this issue. But I think, if I'm not wrong, I think it's a multi-year work plan, nowhere close to arriving at any consensus on this issue. So in the meantime, and because the UN processes do need to take a certain pace of time, you have countries and groupings like the US, right? They have come up with the Artemis Accords. They've tried to, I think, elucidate perhaps the next level of detail, right? That can help with the discussion. So what the Artemis Accords say, for example, is that they do not equate the use of space resources to national appropriation, right? And so that has, in a way, pushed the conversation a little bit further. And so I think we're going to see, more and more discussions taking place. And in a way, more and more, the level of detail will start to deepen as we go along. But it's just something that's going to take time. But I think in the meantime, the companies are already pushing ahead with some of these things. We will see commercial players, right, going to space and really attempting to use space resources for certain activities. I mentioned earlier that there are folks working on turning lunar regolith, right, into water, oxygen, hydrogen, even extracting precious metals. They're doing it in very small scale, but it's just a start. And it's just a matter of time before they can scale up those activities. So the question is whether the rules and the norms can catch up. But if not, I think these guys will just go ahead. And the US, Japan, Luxembourg, they have passed national legislation that have enabled these private actors to go ahead with those activities. And I think, we will just see that happening and wait for the norms and rules to catch up. Perhaps very quickly on the first question. Yes, I think already it's perhaps an open secret, right? That a lot of the satellites that are already up there providing communications, providing Earth observation, remote sensing kinds of services, they do also serve the military, right? I mean, if you're talking about Maxa, if you're talking about, I don't know what else, Airbus, the imagery that they take using their satellites, their customers also includes the military, right? Then communications that you mentioned, the most obvious case is Starlink and Ukraine. But I'm pretty sure that other militaries also have access to their own satellite communications providers. So it's a very interesting question of law. I'm personally not sure that there's a legal answer to that yet. I don't know if the other panelists have thoughts on this, but there have been some that have said, of course, that once you use civilian assets purposes, it's the international humanitarian law, etc., comes into play, and they become a legitimate military target. But in a way, it's not a straightforward answer, because when does that get triggered, right? So I think there's a lot of thought and discussion that still needs to be put into place to, I think, work out some of these things in detail. Because if you're talking about space technologies in general, almost everything is dual use, right? You can, so how do you, in a way, draw that line, figure out when exactly, IHL applies and when it does not? I don't think that's really been an area that's been discussed significantly, nor have there been any real test cases to help push legal development along. Yeah, maybe let me stop here and hand back to you.
Sure. Thank you so much. I think those were very pertinent answers. At least, I found them very, very useful, and so would be our viewers. And as you said, there are no easy answers to this. Can we now go to Dr. Raji before we go to Professor Nagappa?
Yeah. Sure. Thank you. And in fact, I just want to touch upon and start with the last point Mr. Lake was making about the dual use nature of space assets. And that's a huge problem. And especially given the kind of competitive dynamics that we see in space, would a particular state A, for instance, want to target state B's space assets? But that state B's assets are dual use. It's not so the state A is thinking of targeting a military satellite. But the fact is that given the dual use nature of many of these satellites, this is a targeting complication. But if targeted, how do states respond? How does state B respond to a sort of an attack from state A? That is a complication. Another complication is increasingly, for instance, there are industries which are carrying the payloads, which are launching the satellites. If that is the case, again, if there is an attack that has happened, an industry payload has been targeted. Industry may be carrying the state payload, again complicating targeting, as well as how would you resolve this particular thing? Would the state respond? Would this private industry be, because private sector again has put in a lot of money, so they have a financial stake. They have just like the state, but there is also the commercial actors are going to be driven more by profit motives than other aspects. So in a sense, who responds? When do you think? What is the proportion of response? A whole range of questions that will come up in a sense, and I think that's part of the problem that we are increasingly seeing with the private industry players carrying mixed payloads and kind of things. On the question of the space blocks that are increasingly emerging, of course, the US and USSR, after pursuing military space program, conducting a number of ASAT tests and kind of thing, both sides came to a decision that was not in their own interest to carry on with kind of destructive activities and destabilizing activities, and thereafter they put an end to it. But today's international political climate is such that nobody is showing that kind of a maturity. The divisions are becoming much clearer. The blocks are emerging pretty much loud and clear, and there does not seem to be some sort of any meeting point, any sort of compromise between these two blocks. On the one side, you have the Russia-China combined, which continues to insist on a legally binding treaty measure, as if the legally binding measures are going to ensure good behavior, responsible behavior. That is not really the case. You have plenty of examples even in the Asian context where countries have signed on to a legal piece of paper, but then have violated every single commitment. You can take the example of nuclear proliferation to any other issue. There are plenty of examples. So signing on to a piece of treaty is not going to give you any sort of guarantee that states are going to be responsible, states are going to not interfere with each other's satellite. The simple fact is that if you can abide by, if you can come to codify a set of principles as these are commonsensical, pragmatic things that we need to follow, not to throw garbage into my neighbor's backyard. That's a commonsensical thing. That's something that needs to be, but increasingly it seems like that those commonsensical principles we have to codify and put it in a political instrument or a legal instrument, or not to interfere with the TV antenna of my neighbor. That's a commonsensical thing, but increasingly it seems to be the case where we need to emphasize in a treaty or a political agreement, because without that, states are increasingly interfering with each other's satellite activities. So so the divisions are very clear, and there is just no narrowing down of the differences between these two. And so the second block is the US-led Western countries, by and large, which insist on political agreements. And I can see the argument from their case, because as a if I sign on to something, I will play by the rules of the game. That is, by and large, the US and Western concept of how they have done things, by and large. Whereas China, for instance, it signs onto a paper, violates those commitments, whereas you get the other parties to sign on to something, and that is binding their own capability development. So there is a serious problem, and therefore the Western group, by and large, are in favor of political instruments, because there is also the huge mistrust or distrust, lack of trust among the and confidence among the major powers today. So we are not in a place where we have that confidence in each other to sign on to a legal piece of a binding mechanism. We are not in that place. So first is we need political agreements possibly to start building precisely that confidence in each other. Engage in openness, engage in transparency measures, so that it gives each other some bit more confidence, so that we can sign on to something much more legally binding and so on and so forth. But I don't see that happening in the immediate. And that is precisely why you had the group of government experts, the UN measure in 2018, 2019, ending in a failure without a consensus report. Similarly, the OEWs, the open-ended working group that just finished the meeting, again, ended without a consensus from the report, from the deliberations. All of this shows how things are becoming more and more difficult. And you talked about the ILRS, the Artemis Accords, the International Lunar Research Station, which is a Russia-China proposal, and versus the Artemis Accords. And India, for instance, how was India looking at it? And India clearly, would have wanted to participate, work with Russia, but at the same time, Russians have grown far closer to China. That is number one. And a measure like the ILRS, which is also led by China, was clearly not going to be an option for India to work around. So countries like even India had to finally make the choice and go with the Artemis Accords. And I think that's in line with the growing kind of trends that we are seeing in terms of all of our new security partners, primarily in terms of our ability to manage China, comes from the new security partnership, whether it is the US, Australia, Japan, France, and Singapore, and Vietnam, Malaysia, Indonesia, all of those. So increasingly we are with that group of countries, because I think that's what, because we all have a similar worldview, similar shared sets of concerns about the problems coming from certain quarters, China, Russia, and so on and so forth. So are we looking at space alliances? I don't know whether, possibly we are looking at some sort of an alliance, some sort of a bloc for sure, because there are differences among these two blocks, like I said, in terms of identifying challenges, in terms of identifying possible ways to deal with them, the solutions, and also in terms of where we should be discussing these challenges. Is it the CD, the Conference on Disarmament in Geneva, which is traditionally the venue where we discuss space security related or arms control issues? Should we be discussing them there, or should we discuss in purpose, the Committee on the Peaceful Use of Outer Space, which is a civilian body, peaceful applications of space oriented, which is a body based in Vienna. So there is a debate a disagreement among these two blocks, also in terms of where we should be discussing. Just to give you one example, space debris, which has become an increasingly problematic issue, which has become a growing challenge. In fact, when more than a decade ago, we brought out a book on the International Code of Conduct for Outer Space Activities. And one of the chapters was written by an Estonian space agency leader. His chapter title was "It Happened to Us." He was referring to the one and only satellite that the Estonia had launched, and that was destroyed by a space debris piece that was part of the Russian, part of the Chinese 2007 ASAT test from a large debris piece that went and hit them. And that was, so, space debris is already a big challenge, but Russians and the Chinese say space debris is a civilian issue, peaceful, because that's, debris created by the old junk that is lying around in space, and therefore it's a civilian issue. It should be discussed in the purpose. They are not considering the space debris that is created deliberately by the deliberate actions of states through actions like conducting more ASAT tests. So large number of countries believe that space debris that is a result of the man-made intentional attacks, that has to be really part of the CD debates, Conference on Disarmament debates in Geneva. And again, there is just no agreement among these two sets of countries in terms of where we could even discuss these issues. Space weaponization, our countries weaponizing as a kind of a leverage. Part of the debate, part of the calculation is possibly that before a new NPT kind of thing comes out, you want to have your own capability so that even when the International Code of Conduct of Outer Space was debated in 2011, 2012, which was an EU proposal, there was a debate about whether India was going to be part of it. India did engage in a lot of constructive debates. I was part of many of the debates that happened in various parts around the world. But the fact was that finally, when India conducted the ASAT test, and I was told that we conducted the ASAT test, so we couldn't have signed on something. But the fact was that the code of conduct was not going to limit your options ability to demonstrate a ASAT capability. But the fact is that countries do think about these aspects when looking at global new rules of the road. And India has been very mindful of how an NPT-like mechanism could come out in space, and that could really bind India's measures. But the fact that India joined the Artemis Accords clearly shows that we want to be on the ground floor as far as the global debates are concerned. So get on with the other, I think, 35 odd countries who are part of the Artemis Accords, be part of the deliberations right from beginning in terms of developing certain means of how lunar cooperation, lunar governance is to be done, and so on and so forth. So I think these are certainly calculations as we go along. Yeah, thank you.
Sure, thank you, Rajiman. Professor Nagappa.
Thank you. Interesting discussion points. Yes, I just wanted to react to one or two points with Mr. Lekman. Very interesting, this one. The Dove series of Planet Lab satellites, they provide coarse imagery, fairly good imagery, but imagery of the whole Earth every day. And including the news channels use this in India for analyzing the Ladakh situation on a day-to-day basis. Very, very amateur people who are sort of looking at what tools are available for interpreting. So these are actually, as far as the company goes, their profit making is their major this one, and they're providing a service. And the service has both civil use and military use. How you really going to look at those elements and bring them into some level of governance? I don't know. All you can see is this area will not allow you to map. Maybe you could do some of those things, but then how many satellites can you blind? How many satellites will do this one? It's out of question. I don't think you can kill those satellites. Raji made some interesting points also. I just wanted to add, right now the Artemis Accords is between NASA and individual countries. It's not one blanket accord. So I don't know, each of these countries, including India, may be driving in a different fashion. You have to keep that in mind, therefore, somewhere or the other. It's all of us agree saying that the OST based on 1960s technology is definitely outdated, needs to be re-looked at with the current technologies that are available. It's going to be a tough job, as Daji has pointed out. No two sets of CD as well as this one come on terms where exactly you go to, but you require a proper forum, perhaps the United Nations had certain more appropriate rules on this one. I don't see the possibility of a banning of the debris producing anti-satellite tests, for example, happening. Even we would like to argue whether if you can confine the debris to less than 300 kilometers, therefore the debris will be short-lived. What is the harm in allowing it? Why should you ban all ISAS tests? You could look at various aspects of it, to ban, not to ban, partially ban. So there could be issues of that variety you can have a look. Coming to the specific question which Yogesh posed to me, is ISRO's mandate shifting? I think all of us know that space deliverables are dual use in nature. I can use the same remote sensing satellite for societal application. I can also use it for military applications. And right now, the services and the results that are coming out of ISRO system, they do co-serve certain military needs of the Indian military also. In fact, the Indian military has their own data information downloading center as such. Okay, so the Indian remote sensing satellite data is directly available to them for study, interpretation, and if necessary, perhaps even request a particular imagery if they want. So they co-serve the needs right now, and they've been with it. Keeping that in mind, looking as the resolution increases and all that sort of thing, there's a certain set of satellites. Cartographic satellite, for example, 1, 2, 3, I think they give us certain type of limitation. Precise imagery, which can be used definitely by the military, and most probably it is being used. In addition, you would have known, this has not been done, but then if I look at the capabilities which ISRO has produced, those capabilities can be very comfortably translated into this one. ISRO satellites, you can inject them in different orbits. You can change the orbits if required. You can change the inclination. It's all a question of expending extra fuel to do that. And that's where exactly how you configure. But the technology is available for you to really twist it to or tweak it for a military need very comfortably. In addition, I think there was a ASAT test itself, the microsat, which was the target satellite, was really a law intent said it's a Earth observation satellite. It was in low orbit, 74-kilometer orbit or so, and then you train your kill weapon to take care of it to proving a certain things. There's also an radiation emission satellite which is currently doing. These are definitely specific. So the mandate per se is not shifting of ISRO, but ISRO is also catering to certain military needs. It's a demand-driven this one. So right now, the Defense Space Agency, it is there. It's perhaps still getting into shape. They don't have any launchers. They don't have any satellites. So either they have to order with a private company saying, this is the specification, build it to my requirement, or order it with ISRO. Incidentally, in this regard, the GSAT 7, 7A, 7R, 7B, these are exclusively for the militaries, the communication satellites. So mandate is not, strictly speaking, shifted, but ISRO is also catering to military needs, that we put like that. With regard to the funds required for research, yes, ISRO takes pride in the fact saying that we do affordable cost research capability we have, and our launch missions, satellite missions are more affordable than other countries. This I really don't know how exactly do you cost it, in the sense private enterprise has a different costing methodology. We have a different costing methodology. fortunately or unfortunately, people working in ISRO are government servants. And when we cost it this one, we don't look at that because the salary component we pay, we don't call it. The Americans say it is subsidy. It's not subsidy. They're employed. They're paid by the government. But their cost, this one does not get into the costing of the satellite per se, except for a general overhead type of this one. So this will continue to be so, but then over the picture time, with private players coming in, miniaturization happening, and a lot of in-house capability as well as in-country capability that has been developed, I think these costs are continuing. I think India will continue to be very, very competitive in this field. And having realized, looking at the market, I don't see the necessity right now for India going for reusability as a concept to bring down the cost of access to space. Even otherwise, we are cheap. And then keeping in mind the small satellite market which is emerging, India has now created a small satellite launch vehicle also exclusively for payload of the order of 500 kg. You need not even go as a piggyback ride on PSLV or GSLV, you need not pay. So these type of facilities or capabilities are being done. And probably the private sector is going to make money out of this also. There are two players in the private sector who are offering launch services. They're coming up fairly well. So, and I think there's a yardstick for them. ISRO charges only so much cost per kg, and if I have to survive, I have to make within that. So this is a yardstick with which they have to measure themselves and do. So it's a good competition, good target to set, saying that do within this cost. If they are out of it, then what is it? But as you say, some facilities at ISRO have been made available. The launch facilities at Sriharikota have been made available for the trial launch of the Skyroot sounding rocket, the suborbital rocket. So these facilitates this one, but this is not free for them. Those guys will have to pay for the services. Maybe the services are not very expensive because our facilities are quite old, but they still serve the purpose. With that, I'll stop. If there are any further questions, we can get back.
So I cannot let go, even if we are over the time. But there are two audience questions, one specifically for Raji ma'am and one for Mr. Lek. And Raji ma'am, you can, put your interjection when you reply to that question. So the first is, this is not just a prestige issue. This is, the space race is also about.
You got muted.
Okay, the AI taking over, I guess.
Exactly.
So,
sorry.
This is not just about prestige. This is also about influence in global South, right? So, what can India do after Chandrayaan moment for countries in Southeast Asia, in Africa, in global South generally? That is one question. Another question for Mr. Lek is about Singapore-India space cooperation. How is Singapore looking at India in terms of space cooperation? And we see both government to government cooperation, but also private players in Singapore cooperating with private players in India. So if you could quickly, comment on those two, and you can also make your interjection, Rajiv.
Sure. Thanks for that question. No, I just wanted to start off. I just wanted to make a quick interjection, sort of a 30-second point about increasing difficulties in terms of deciding where to discuss between the CD and the COPOS. In recent times, there has been another route many states have preferred taking, which is the UN General Assembly route. So take it to the UN General Assembly, put up a resolution, take it up, and that's how the whole open-ended working group came about as a result of initially a UN GA Security Council resolution put up by the UK and a number of other sponsoring countries. So that's another route that we are increasingly taking, given that contentious nature of how to work the CD and the COPOS. On this whole question of, yes, of course, this is a matter of prestige, of course, but beyond prestige, whether it is Chandrayaan or Mangalyaan that India did in about a decade ago, close to a decade ago, or even larger, some of the missions that India is doing, I think there is it is driven by practical value in terms of strengthening one's own security capabilities when you look at some of those military space satellites and kind of thing increasingly we are doing, or the ASAT capability. Again, ASAT capability development was done with a clear message towards China that if you mess around with my satellite, I have precisely that capability to inflict pain on you. And again, there are questions about one ASAT is going to have that kind of a deterrence value, but that's a separate issue. But again, the point is to make that, so there are security, but in terms of the global south and how the developing world looks at it, in a sense, I think India's space program has been hugely inspirational for a number of countries. And especially when India undertakes complex missions like Chandrayaan or Mangalyaan and kind of thing. And of course, next year, when we do the Gaganyaan mission, the human space mission, these are hugely inspirational because they look at India as a developing country, but that has aspired to do big things with regard to with some of the critical technologies like outer space in a sense. So they feel that if India could do it, that's also a kind of it gives us a sort of a hope and inspiration to develop your own kind of capability makes to develop your own STEM force, your scientific and engineering base in a way so that you can also aspire to do something. Because whether you do it for military purpose, security related purposes or not, because those are all coming together at a much later date. Initially, a lot of countries, most countries around the world went into space because it was going to change the lives of the people socially and economically. For a number of countries, this was going to be a game changer. Space is being used for a vast, so a whole lot of developing countries have actually, whether it's in Latin America, Africa, or even in Asia, they've just begun to appreciate as to what space can do in terms of changing their lives. And there are therefore going to be more countries. So especially when they look at countries like India, which are actually managing to do accomplish a lot with a small, tiny budget, it becomes a source of inspiration to say that this is something that others can also do. It is not just something that just the two major powers, great powers do, but other developing countries can also aspire to do something of this kind. So it has that each mission that India undertakes is also kind of a very inspirational aspect for the global south in a sense.
Thank you, Mr. Lek.
Yeah. So on Singapore-India cooperation, I think there is already cooperation taking place on a number of fronts. I think first, of course, through ASEAN. I think between ASEAN, of which Singapore is a member of, there is an ASEAN-India work stream, I suppose, on space cooperation. So that's already one level of work that's ongoing. Of course, in terms of launch as well, I think Singapore is a big customer when it comes to ISRO launch services. And if I'm not wrong, I think some 20 of our satellites have been launched just over the last, I think, 1 or 2 years, on an ISRO launcher. So that's obviously an area that I think Singapore is keen to collaborate with India on more on. But I think there are also perhaps areas where I think there are certain niches that both Singapore and India share. I mean, being in the region that we are from, we do have certain unique needs. So, I mean, one example that I can think of is that, in terms of remote sensing, for example, if you're talking about serving agricultural needs, right? A lot of the remote sensing algorithms that have been developed today are really very much focused on, say, the North American market, where you're looking at huge farms, right? And you're talking about assessing the health of the crops, what you can do to manage those crops. But I think in Asia, that's very much, that's not quite the model we have here, because in Asia, a lot of our farms are much smaller, small holdings. So, you kind of buy the same processing algorithms, etc., for remote sensing data. So I think countries in the region, those that have the capabilities, do need to work together to make sure that, the data sets and solutions are tailored in the way to our own needs, right? So this is just one example, but I can think of several, not just in remote sensing, but perhaps in terms of satellite communications as well, where there's potential for technological or research collaborations between both sides. On the private sector side of things, again, I think there's a lot of scope, to further interactions and to encourage folks on both sides to work together. I think Singapore in particular, we are a major hub when it comes to venture capital. So if you look at, we're more than 200 VCs in Singapore. In fact, even in terms of accelerators for startups, we're more than 200 accelerators. So already I know of a few, Indian startups that are coming to Singapore to tap on, these opportunities that are available here in terms of acceleration as well as in terms of financing. And in so doing, I think there's also that cross exchange of experiences and talent that can only benefit both sides. And again, I know of Singapore startups that also are looking to expand to the Indian market that actually have set up an arm in India, tapping on, I think, the workforce that's there in India that's very well trained by Israel over many years. So I think some of these startups, whether it's based in Singapore or in India, many of the founders have actually spent time with Israel or with an Israel contractor and so on and so forth. So I think there's that connection already, and I just hope that that connection or the number of connections can continue to grow, and that we can build on this to really build better things for both sides. Yeah.
Thank you. With that positive note, we should end today's session. I really thank you all for not only giving such wonderful presentations. I personally learned a lot, and I hope that all our audiences learned a lot as well, but answering my questions and answering the questions of the audiences. So thank you so much. Hopefully, we will meet again on a bigger roundtable or an event discussing some of these very complex but very pertinent issues. So thank you once again, and have a good day, all of you. Thank you.
Thank you.
Thank you. Have a good day. Bye.
Okay, bye-bye.